We'll talk today about Polkadot SDKs, Papi SDKs actually, Polkadot API SDK. So do not confuse with Polkadot SDK, different things, very different goals and all that stuff. So you remember that we said that Papi is agnostic, right? Chain agnostic. That's the limit of Papi. So until we try to abstract everything away, except at the point where we start being picky on which chain are you connected to, essentially. So which is the logic of the chain that you are connected to. We don't want to do that, but Polkadot API SDKs or Papi SDKs want to accomplish that. Because you remember that we said that some interactions can be tricky. For example, you are having a hard time with one, which is staking. So for example, there could exist an Polkadot API SDK for staking. Actually, it does not exist because it's your assignment, and if it would have existed, yeah, kind of easy to cheat, isn't it? So, yeah, essentially so today will be more of a hands-on session, right? We will talk a bit about Papi SDKs, and then we will talk about Ink, the smart contract language in Rust for Polkadot. And then we will have some time for assignment questions, issues, or whatever. So yeah, Papi SDKs, what are we going to see? First, which is the motivation, which are the goals we are trying to accomplish with them. And then we will take our governance SDK as an example for illustrating what's going on, what we are trying to do. And afterwards, we are going to build our own SDK. Well, you are going to build it, just going to give you some guidance. So, cool enough. Then, the motivation behind Papi SDKs. What we said, Papi is agnostic to the runtime, right? This has to be super clear. So when you create a client for Papi, it does not let you say in natural language, if you wish, like unstake 10 dot. That Papi does not understand that. So you need to explain to Papi what exactly are you trying to do. With Papi SDKs, we try to simplify a bit this. And the idea is to build an SDK whenever it makes sense, right? So for example, if I'm trying to get the free balance of an account, that is fairly easy, right? API.query.system.account, Tuki, my account, .free. Okay, good. But as I said, there are other interactions that are more complex. And that's the idea. Do not reinvent the wheel, but simplify as much as you can, which is the methodology we took for these Papi SDKs. So you will see that we have some of them, and all of them are like create SDK, and then you have to pass a typed API, and we will see why a typed API and not a client. So the function, the SDK function, already defines the types. So already tells the consumer which are the types inside the typed API. So essentially, which are the descriptors, or how do the descriptors have to look like to work with this SDK, right? And if it's not compatible, for example, if it's an staking SDK and you pass a typed API of Asset Hub, which has no staking functionality just yet, it will blow and say, no, I can't work with this. This is not what I was asking for. So it already gives feedback from coding, from the point you start to code to the user if it's or it's not compatible. And the idea is to make incremental releases. So see, this is the same methodology we took with essentially every library we built. Instead of starting with a shit ton of APIs and all of them very small and very particular for every use case, we start with a small set of APIs, which we know, yes, they are going to be super useful. And then as soon as the community starts asking, yeah, I think it could be interesting to do this. And then we can have a discussion and decide if that's good or not. So then we make it incremental, right? Because imagine that we start with a big API, right? And then we see that a function, it's actually not very useful because you can compose 2 other functions or whatever. Then we might think, yeah, we can remove it, right, in the next major or whatever. But yeah, then we will broke someone's app. So it's better to essentially tell the community how to use these small APIs, and if they need another one, we can add it, but being very thoughtful. Does that make sense? Good enough. Then, which are the goals for the Papi SDKs? Main goal, simplified app development. For example, we saw some of your assignments that included identity, like, so you remember that we talked that an address can set their identity, say that I am this person or this group of people, and whatever, essentially explain things about themselves. So we saw some dApps of your own that had identity features. So when instead of seeing the address of a validator, we saw the address and as well the identity on chain, which it's valid. But this small feature, it can be added to every dApp, and it does not have to be different. So it's the same for every dApp. Has to take from the people chain the information and display to the user. So this can be simplified. So an identity SDK could be accomplished because it simplifies the dApp development. Then the idea always is this one. So the dApp developer should focus on what it's doing in Polkadot ecosystem, not how is it doing it. Does that make sense? So we don't want the dApp developer to be going mad about if the types or if the whatever, or if identity, do I have to spend 2 days now understanding what identity is, and then I find these shitty types that no one understands, right? So let's make sure that the dApp developer focus on what it's doing and not how it's doing it, right? And also another cool thing is that, as we said, the runtime of Polkadot evolves fast, and there are a lot of upgrades during the year, maybe 6 or 7 updates every year. So it's easier for the SDK developer to track the palette upgrades before the upgrade hits mainnet, right? Because it's a very small feature, right? So it's identity. So I just, me as an SDK developer of identity, I just have to track identity palette. I don't have to track the whole network, right? And if instead of that, the user was building everything by himself, the user would have to track identity palette, but also staking palette and nomination pools palette and whatever. Does that make sense? So it's in the end, it gets easier to avoid crashes due to runtime upgrades. Yes? Yes, I see many people very concentrated. I guess SDKs are super interesting. Yeah, so governance, this is an example, right? So the idea is that we want to abstract as much as we said the whole time. Oh, yeah. I hope I will not be super cold. We want to abstract as much as possible the interactions with the governance, right? So voting and opening referendums and whatever, all these kind of things. And we discovered that there are, I say here 3.5, but actually 4 main groups of functionality, which are referenda, conviction voting, and then this is the 3.5, right? So bounties, and then the half-child bounties that actually it's separate, but it's style decoupled, so it makes sense to have it a little bit together. So in referenda, which problems did we identify? First of all is that the state is split all over the place. So among different storage, constant entries, for example, referenda info for, referenda tracks, and even there are parts of the state that are not available to in our API, right? So const or queries or all that stuff. This is not our fault. This is the fault of the palette developer that didn't expose that information in the metadata and to the outside, right? So they require some parts, right, that need to be hard-coded or at least configured per chain, because we cannot know it on real time. So what is it that we want to include in the SDK? First of all, we want to be able to fetch referenda and get the information about them. Essentially, this part is abstracting the storage. So the storage is very messy. It gives you information about the track with a number that it's not very It's very difficult to understand. And then there is also some extra info that is interesting. So when is the poll expected to end, right? We can calculate that from outside, and it's interesting for the user. So I'm seeing a referendum, and maybe I can show to my dApp developer, my dApp user, that yeah, this poll is expected to end in 2 days, and actually it's going to pass, or at the moment it's passing. We can also resolve the pre-image. We will see what does this mean. We can decode the call. So when this referendum gets executed, this call will be executed by this origin, right? And all of these things. So we will, let's see in the, oh yeah, I'm not showing here. Yeah, let's see in the, in Papi how, what do these storage look like? What's that? We have to wait for a small dot, so you have plenty of time. Shout. Okay.
No, I was just saying that, like, you're mentioning like a bunch of you know,
A bunch of?
you're mentioning a lot of things that they're probably not familiar with,
Yeah, exactly.
like the pre-image, like you're.
Yeah, exactly. That's why let's see in real life what everything means. So, for example, let's see one referendum. I don't know if you're familiar with them, but there are some front ends. Oops, where? What are you? There are some front ends for governance in general in Polkadot. One of these is Subsquare, which is this one. So let's take one simple, this one, for example, just retroactive compensation 3.0, whatever, right? This is the referendum 1704, right? So let's see which is the information that the chain gives. It says that the referendum is ongoing, okay? It says track 33. Who knows what that means? It says that it will be executed by medium spender, okay? And look here, it says the proposal. So this is the call that will be executed when the referendum passes. It's of type lookup. This is the hash, and this is the length. This is very, so imagine if you find this, so you ask the chain, and they give you all this information. It's like, most likely you will need to spend a day or two understanding what does everything means, right? So essentially, what we do in the SDK of governance is abstracting these kind of things. For example, track 33. This is an index, and if we go to the constants, if we now go to the constants of referenda, if I'm not mistaken, tracks, we already have some items here, right? Item 1, 0. Item 2, item 3, item 4, blah, blah, blah. So if we look for 33, where is item 33? Yeah, here, found. It actually says that it's of name medium spender. It's max deciding 50. This is the decision deposit you have to place. This is the prepare period. This is the decision period. All of these numbers, you need to understand them in order to, for example, calculate when is the poll expected to end. But actually, for the dApp developer, if he's not super into referenda and he just wants to implement that have that feature in their dApp, he does not need all of these. He just needs simply what to show to the user. So this referendum is ending that day. Okay, it's enough for the user. We don't need to understand all of these. And that's why this is abstracted. And as well, some information about the tracks, it's not available, as I said. So we also take it into account as a configuration-based part of the SDK. So hard-coded part of the SDK, but it is needed to understand. This is relevant. So the part that is hard-coded, it's relevant to submit referendum, not to read them. But anyways, it's important. So the second part that we wanted to show. Yeah, question.
No, like what he mentioned about not being available, just in case that you use it one day or that one day you end up working at parity or something. Can you go back one moment to to the constant where like, well, the part that is not available is the threshold. Like you see how there are like different tracks that are for requesting money, and they are called medium spender, maximum spender. So the threshold of how much you can spend through each one of these ones is actually hard coded into the runtime. Like these values do exist in the runtime. It's not like these values are made of thin air. They're in the runtime, but sadly they are not exposed through the constant. So they should probably be exposed either through a constant or a runtime call, API, something, a view, whatever. They should be available. Because they are not available, our SDKs, they force you, as Carlo explained, to pass these values. The problem with these approaches is that if one day these values change on chain, there won't be a way for anyone to know that that has been the case. And then the values that you pass will be wrong. So if one of you ends up working at parity, or if one of you wants to contribute, it will be beautiful if one day we have these values on chain, basically. So yeah, like as Carlo explained, like one of the things that the SDKs do as much as they can do, given the constraints that we live in, basically. So sorry for hijacking. I just thought that it's important that you know exactly what it is that it's not that it's on chain but not exposed to us.
Yeah, go ahead.
Okay, so my guess is with that hash, you'll be able to find in the Patricia Merkle tree like the info you need, and that hash updates if you change anything related to it.
You mean this hash?
Yes, exactly.
Yeah, I was going to talk about that now. So this touches another palette. So essentially, there is so as we said, the groups of functionality in Polkadot are split in palettes, right? But some of the palettes interact with each other, right? Remember what we said, that balances palette, for example, when you do a transfer, it interacts with system palette, with actually the storage in system palette. Does that make sense? So in this case, this is the way we have in Polkadot to store data on storage is using pre-images. So actually what this is saying is that as soon as this call gets executed, you will need to go to the pre-images palette, which we remember that is where we store arbitrary information, and you need to retrieve in that map the pre-image that has this hash and this length. Okay, so let's go and check if that exists. Let's copy this. 351 is the length. Let's go to storage. Where are they here? Pre-image. Pre-image 4. Then they already ask us for the hash and the length, 351. Let's query. Let's see if it exists. It does. So this is a bunch of bytes, which we already understand because we understand the logic of the specific palette. This is a call, right? So if we go to extrinsics and put it up here, is this prepended or what? What's that? It didn't copy the whole thing, or 1A? No, it didn't copy the whole thing. What? Yeah, because okay, because yeah, it's copying the opaque. Okay, fine. Let's remove the opaque. You remember that we said that so as sometimes when we store data, we do this double encoding, right? So first encode the thing that we are trying to put here, and then afterwards we say, okay, this is a vector of bytes, and I prepend the length in compact, right? We mentioned it multiple times. But yeah, whatever. So if we decode it, actually what it says is like, okay, let's close this. The call that is going to be executed is a batch all. So remember, we will execute all of the calls inside here. And the calls are treasury spend. Okay, whatever. They will try to spend all of this. All of this means USDT. or USDC. So all of this means, all of this asset kind, which is super crazy, means USDT. So they will spend this amount to them in USDT. Okay, and besides that, they will post a remark, which is beyond retroactive compensation, approval of this proposal signs the community support for our continued contributions to the Polkadot ecosystem. Blah 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 blah. Okay, yeah, okay. So actually, because this company, what they are doing is working before, and then they post a referendum saying, we did all this work. Can you pay us for all this work we did? So besides getting paid for the work, which is this treasury spend that we said, they are getting some USDT or USDC. They are also posting this remark saying that if you approve this referendum, you are signaling as well that you want to support our work. Okay, massive. So with this information, we can actually decide if we want to participate or not on this voting, right? And with yes or with no, with aye or with nay. Does that make sense? Okay. The thing is that sometimes in referendum info 4, which was this one? Okay. Sometimes the call can be embedded here. So instead of, in this case, I got a different one, but whatever. Instead of having these shenanigans with the pre-image that I have to go to another palette and get the value and then understand the value, we can have the call directly embedded here, right? So saying, yeah, the call fits here, because there is a limitation in size. The call fits here, so I don't want to pollute the state of another palette and rather execute this call that I'm providing to you here. So all of these small caveats, either you need to figure out yourself in your dApp or to use one SDK that already wraps everything for you. Does it make sense? Yes? Okay. Oh, in this case, I got a referendum for Ross and Joel, Polkadot Cloud. I don't know them. Not sure who they are. So, okay. You can see. Now you can see. Okay. Do you know them? So, blah, blah, blah. Yeah, it was the part of abstracting storage. Then we also want to help with the creation of the referendum. For example, let's say I want to create a referendum because what these guys did, right? They did a bunch of work and they want to get money back. So essentially a spender referendum, easy. Like as soon as you approve it, you give money to me, okay? But then remember what Josep said, that there are multiple tracks for spending money and not all of them accept the same amount, right? So there is a track to give, for example, a tip to Carlo because he's a super good teacher, right? But then there is also another track, which is to, I don't know, pay for the whole PBA the whole year, right? These are different amounts, and therefore they require different levels of conviction, different levels of voting. So more people has to vote, and with a higher percentage of ayes in order to get executed for the one that is spending a lot of money. And for the tip, if someone votes and says, yeah, super good, yeah, let's give $10 this guy, this is not that difficult. So as soon as there are some votes, the call can be executed. Does that make sense? Okay, but then how do I know which track do I have to use to create my referendum? Let's say I want to, I don't know, say get $50,000 for me and to continue my development in whatever tab, whatever. What is $50,000 so is it a high amount? Is it a low amount? Is it a tip? Is it a medium spender, a small spender? So all of that, the SDK already tells you, given this amount, this is the track you have to go. So the lowest track that accepts that amount. Let's see how we can create an app, referendum in here, referenda, submit. Yeah. So first of all, we have to choose what we were saying, right? Is it a, let's say, only spenders, for example. Is it a small spender? Is it a big spender? Is it a medium spender? Is it, if I want to, for example, update the chain, update the code of the chain, I have to say root, right? So what do I have to choose? The SDK helps you with that. Then enactment moment. When do I want my call to be executed? Do I want it to be right after it gets accepted, let's say, or do I want to wait until my birthday because because bananas, whatever. So this you can choose. So for example, after 10 blocks or 100 blocks, or I can say at block number 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, because yeah, it's a nice number, and I want my call to be executed this day. Okay. But then the proposal, this is what I said. Lookup is what we already saw, right? This hash with this length that we already submitted to pre-image palette. But it can be also inlined, right? So saying this is the call I want, this is the call I want to execute, and I put it right here. And how do I know if I can inline or if I have to create a pre-image? Because creating a pre-image costs money, and also you have to leave a deposit. So if I can inline, better than using a pre-image. But how do I know if I can use one or the other? So that the SDK takes care of that. So as you can see, there are a lot of caveats and small shenanigans about the palette that either, yeah, in the end, either you have to understand or use an SDK. Does that make sense? Good. What else? Yeah, what we said, figure out where referendum should go and abstract the pre-images. Okay, what we don't want to include in the SDK, because not everything has a place in here. Yeah, go ahead.
So usually the updates to the runtime, do we like add them by like adding the pre-image, or like do they go in line?
What's that? Can you go ahead?
So for like referendums related to like maybe like making changes to the code itself. So do they like usually go in line, or do we like usually create a pre-image for them?
The only limitation on what can go in line or where can go in a pre-image is just the length. So I think it's 128 bytes. So if the call exceeds 128 bytes, then it has to go to a pre-image. If it's 128 or less, it can go inline. But this is something that it's so there is nowhere in the constants or in the query or whatever that you can ask for the, I don't know, the longest, which is the limitation in size, right? You have to know it by looking at the specifics of the Polkadot SDK code. I mean, for example, let me reshare. So what you had to do if you wanted to know these things, this is going to be very bad because I didn't prepare it, but maybe it will work. So if I go to Polkadot SDK and say, okay, I want to understand which is the limitation in size, right? So I go to referenda palette, and let's read what there is in referenda palette. Remember that we were calling submit, right? So is this big enough for behind? Yeah. Okay, let's do submit, right? So there is this call, referenda submit, that let's see if I can find it. Where is this? Okay, so this is the call that it gets executed when you call referenda submit, okay? So first of all, they ensure that the origin, so we are someone that signed it, okay? And take deposit. This is probably abstracted in a different, yeah, this is probably here. Insert. Yeah, one thing that it's very bad is that when you try to open Polkadot SDK, they have to build a lot of things before they let you work. So if you ever had this pain, I feel you. Okay, it loaded. Implement, insert. Well, well, this is the thing, right? So that even if I want to find it, I cannot find it now. So imagine if you were like a developer and you have to check every kind of palette for these little things, if they work or if they don't work. So I went to a different file, everything crashed. This is the problem with Polkadot SDK. So honestly, you are very lucky to be here because it's super shitty to work with Polkadot SDK. And when building the palettes, we have to do it. So the SDKs, we have to do it to understand what is going on. So, but we will see more examples of that. Okay, so Tugi, what do we not want to include in the SDK? For example, this function, like place decision deposit. When you create a referendum, someone has to say, this referendum is legit, and I lock some of my money saying that this referendum is legit, and it can start getting voted. Okay, this is to avoid spam, basically, so that everyone starts creating their own referendums, and if this decision deposit wouldn't exist, they were always going to be essentially go. So starting being voted, and the chain would have a lot work to do to check if the referendum passed or didn't pass. So essentially, there is a problem here with spam, right? But actually, this place decision deposit, we cannot add value here because the function, so the call already, if we go to the extrinsics, referenda, place decision deposit, it's already very easy. You only have to provide the index of the referendum. So we cannot help here. There is nothing we can abstract here. This is already easy, right? So if I want to place the decision deposit, if I want to have a button in my dApp to place the decision deposit, it's very easy. I just call to this function, to this transaction, referenda, place decision deposit. This is the index, Tuki. It gets executed, the funds get out of your account, and it works. Does that make sense? Having this in our SDK, the only thing that makes it's making the surface, the API surface, bigger, right? Without adding any value. So this is actually something that we are still discussing, because yes, one can argue that it does not add value because there is nothing I can abstract here, but maybe there is a small value that it's added about discoverability. So if you don't know about referendum, about the referenda palette, and you import the SDK and you see all the functions, maybe you can kind of imagine how it goes, right? So first you create it, then you can get information, and in all of this information, there are some states, right? So the referenda started, the referenda is waiting for decision deposit, the referenda ended, right? But actually adding this function would help with discoverability. So knowing if the referendum that I am now targeting is in this state, so in the state of waiting for decision deposit, if I see a function there that it says place decision deposit, I see, okay, it's waiting for this function to be called, right? So there is no value in terms of abstracting, but there might be value in terms of discoverability. Does that make sense? Yes. So we still don't know what to do. Actually, we didn't add this into the SDK, but someday could appear because, I mean, this is on the fence, right? It's right on the limit of adding or not adding value, right? Someone called? Is anyone called? You are called. Yeah. So can we, because what temperature is that? I don't know, go to 25 or whatever. I will start coughing in like approximately 1 minute otherwise. Okay, so everything makes sense? Cool. Then, before this, let me change the sharing screen. Okay. Thank you, mate. So conviction voting. This is the second part of the governance SDK. What is conviction voting, right? So referenda refers to creating polls, essentially, and managing the state of the polls. What do you think? Conviction voting, it seems to stand for voting in these polls. Does that make sense? And which problems we identified? So again, the problem is similar to the previous panel. The state is split, so it's scattered around many different entries, and so the way it's structured, it's very messy as well, because instead of, for example, I would expect as a front-end developer, or imagine if you are a front-end developer and you are interacting with a regular backend, right? REST API, Web2, whatever you want to call it, and you want to know to which to which tracks this person voted, right? Actually, what you expect is like you ask to the API, and it provides you with an array, a list, JSON, whatever, with a list of which referendum did this address vote, and which was the chosen vote, right? I, nay, with conviction, whatever. In this case, it's not like that, because every track, so every voting track, remember what we said, medium spender, big spender, all of these, they are split. So you have to ask for everyone, so for every track to know all the votes of one address. And why is that? Why do you think is that? So why? Let's see the shape, right? Conviction voting, voting for. For example, I don't think I'm voting. Let's see if is Joseph voting anywhere? You are, yeah. Well, you forgot to remove some votes or whatever. I don't know, 15. I know, because there is a default, maybe, or okay, whatever. But why do you think this entry is split? So instead of having, so what I would expect here is a double map, so account ID, and then the index of the referendum, right? 1703 that we saw before, or which was 1708. Why do you think we have the track instead of the ID? Why can anyone guess? Anyone can guess? So think of a I don't know, a positive thing of splitting it this way, which is very shitty to understand. So yeah, this is split by tracks, but why split it by tracks and not by referendum directly? So essentially the information would be the same, right? Because if we see here, so this is track 15. This is track 15, votes empty, but in this case we would have an array of the index of the referendum and the vote that we submitted. But we could swap them out, right? So having here instead of the track the referendum ID, and here the track and the vote. So actually the data can be reversed easily. Yes.
So for referendums, there's different types like small spend, medium spend, big spend. Can you find these in the constants for these values to know? And is there like a certain amount of conviction that is needed?
Yeah, but this still does not explain. So why, right? So what? So essentially, I get that this is the track and I can have information about the tracks around, but why do I place a track here?
I'm guessing it's for faster querying.
Something like that, yeah. So you're getting closer. Do you want? So essentially, remember what we talked about the nodes in the Merkle tree of the storage. What they are trying to do here is to create less nodes. So if we create for every referendum we vote, we create another node. This will and so this will end up with a crazy shit of nodes in the storage. But instead, if we say only the track, we will only create nodes. So we will only create a limited set of nodes per account, right? Because it will be only the tracks. So this is why they chose to do this, but it might make more difficult to understand what is going on, and it might be more difficult to get all the information for a specific account. Does that make sense? And not only that, what if I want to know who voted on this referendum? What would you do? With your own words, what would you do if I want to know in my dApp who voted? So on this specific referendum 1708, who voted A? Essentially, it's madness because I have to query everything. So I have, first of all, to get all the entries, disregard the address, disregard this, so flat everything, right? Flat all the votes, and then go for every vote and check if the ID makes sense with what I was looking for. So it's crazy, right? Does that make sense? So some palettes, what they have is double storage, if you want to say that. So the perfect thing here would be to have this account ID and then which referendum, but also have it swapped. So in another entry, having the referendum ID and be below that the address, so that I can use one or the other depending on what I want to do. If I want to know where this address voted, I use this one. But if I want to know who voted on this referendum, so all the addresses for one referendum, I use the other one. And we find some examples of that. If I'm not mistaken, was it in Revive, for example? Victor, can you recall? Like example of storage entry that has, so it's a double map and you find two storage entries, one and the other, right? So that, I think in Revive there was one. What? The NFTs, for example, yeah. Let's see, because I think in Revive as well, but I don't fully recall. If the address is, no, with, yeah, unique, what? No, but what did you say? I cannot hear you. If you can. Okay. Yeah, thank you. So yeah, so essentially, let's see if I can find some example now. But another one that works a little bit better. Asia. We're in Asia. Well, where? Let's see if it loads. Ah, yeah. Unique.
Hello, Carlo, I have a
Yep.
question. Yeah. So the reversal that you're talking about, so that's not enabled for all the storages because you are like needing to like find it.
What's that? What's that?
So we are like searching for like filters like based on the referendum instead of like having the address first. So that's not like the double storage. So is it not like enabled for all the like storage that we have? Because like you were like looking for a specific thing which has the double storage entry.
Yeah, the thing is that so they don't do this double storage very much, but some of the palettes have that. I couldn't recall anyone that has one, but the thing is, yeah. So the idea is this one. So for things that are very difficult to get, for example, a good example of that is the tokens, right? In the ERC20s, if you want to call them that way. So the balances for ERC20s, for example, are set in a way that first you query the address. No, first you query the token and then you query the address. Then if I want to know which are all the balances that this address has, I have to query all the tokens to then find that address. Does that make sense? So that's why in some cases they do this double storage. So they store things one way and the other. But I couldn't recall any example of that. So essentially, same that we were saying. The state is scattered, right? The derived state as well. So there is a part to understand how votes can be removed. So when the vote is already done and the voting is, so the voting ended essentially, and I can remove my vote from the state. So understand that. And then remember the vote type, that thing that there was one bit that said yes or no, and then the other bit said the conviction you had. So that is also abstracted in the SDK. Right? So, oops. Yeah. Oh, sorry. Yeah, here. Okay. And then, so essentially, which features did we add to this SDK? Getting votes and delegations for a specific account with extra enhanced information, so an unlock schedule. Because as you remember, when you vote, you can essentially lock your tokens for more time to signal your conviction to that specific voting. So we also provide that information. And as well, abstracting this vote complex type. Then, now, the other part of governance, which are bounties. The main problem that a bounty has is that it can be in a lot of different states. And these are all the different states it can be. It doesn't matter, so don't try to read, but so every ball of, every white round is a different state with different essentially queries that you can, not queries, but extrinsics that you can provide to change the state. So essentially, you definitely have to understand what's going on. Exactly. There are many actions to bounties, right? And they depend on the state they are. So it's messy. Then which features, first of all, do you know what a bounty is? More or less? Yes? Okay. Again, the main feature of an SDK is abstracting the storage, abstracting the state for bounties or child bounties. So in this case, it's the same. That's why I said that there are like 3.5 levels of features, because bounties and child bounties are very similar and tightly connected. And actually, in this case, we expose some, remember that we said that we were not exposing some of the functions because they were not adding a lot of value. In this case, they are value, even if we are not changing the API of the transaction itself, because we make clear to the user which are the relevant actions they can take to a specific state in of a bounty, and then also change so find which is the referenda that change the state of the bounty, because when you start a bounty, you need to fund the bounty. So essentially, ask to the treasury to put money inside it, right? So we try to look to the referenda that are out there to find which ones are relevant to our bounty. Does that make sense? More or less? Okay. Then, last SDK we will see in 5 minutes, and then we will build our own SDK. Accounts. The idea is to simplify common flows, right, for account management. For example, cleaning up, right? Imagine that, so there are some things that leave trace of your account in the state, and sometimes it does not make sense. For example, voting, right? When you vote in a referendum, in the state it's written, I voted here. This state only needs to be here until the voting ends. When the voting ends, so the referendum is already closed, and if it's there, it's just polluting the state. Does that make sense? So we try to make some of these things easier for dApp developers. For example, linked accounts. What is in our jargon linked account? Sometimes it's difficult to identify if an account is a regular account, like a public key that signs and all that stuff, or is a multisig, or is a proxy, or is a combination of them, or is a multisig that inside has a proxy, that inside has a multisig, that inside has a public key, right? This is what we call linked accounts. So the solution we found is that the SDK kind of goes to the tree and tries to understand the whole structure of an account so that you can have a clearer picture. This, for example, is relevant in bounties. Use Papi. Okay. Okay, you see that in this case that there is this bounty, UX bounty, that inside it, so that the curator of the bounty, so the one that the address that decides who is getting paid out of that bounty is this address, okay, which actually our linked, this is built by our linked accounts SDK. Actually, our linked accounts SDK detects it is a proxy, and it is a proxy of this other account. So this account delegated, essentially delegated. So this account can sign on behalf of this one, right? So inside of this, there is a proxy, and actually we detect that this proxy inside here is a multi-sig of threshold 3 of all of these guys. So if 3 of these guys sign together, they will be able to sign on behalf of this account, and this account will be able to sign on behalf of this account. So in the end, 3 of these guys can control this account. Does that make sense? If you have to build all of this by yourself every time you build an app, it's shitty. That's why some of these things can be abstracted in SDKs. And then palette identity. Here, actually, we were seeing 2 SDKs. One is these 3, essentially these linked accounts, and then the identity. So we know this address identified themselves as Braille, or this address identified themselves as Niftesti or whatever. So essentially, that's it. That's basically what I wanted to show you today. No, I have one extra slide. Anyone doubts regarding these ones about accounts? This one should be easier because in the end, it's just understanding how, like, account structure and identity. Yeah.
With the state, is there like a certain threshold before it will be get cleared? For example, a referenda is done. It's been done, for example, like 30 days. Would it be, the state would be cleared, or?
What? Can you go again?
For example, when an account has below 1 dot, his state will eventually get cleared, right? Is
Yeah.
it the same with referendums after a certain amount of time, or are they kept there for auditing purposes?
Yeah, exactly. So the thing is that the chain does not take actions by itself to the state, essentially. So even if our account has less than 1 dot, so if there is no, so if that happens without a transaction happening, essentially, we will not get wiped. So in this case, for voting, it's the same. So we have to take an action in order to wipe the state, right? For when we fall below less than 1 dot, this normally happens when we pay someone, right? We send dot to someone, or we pay the fees. So actually, something is happening, and then the transaction can, that transaction that is going on can wipe our account, because someone has to pay for the fees of wiping our account. Does that make sense? Anyone else? Okay, so one last slide, which are multi-sigs and proxies. Which actually, here we were seeing 2 things, right? One proxy that inside has a multi-sig. So multi-sigs and proxies, our first approach to it were coupling it to signers. Victor explained that yesterday. Remember those meta signers? So actually, this was our first approach. But then we thought that this was not flexible enough, because at some point you could only access the logic of multi-sig palette through a signer, and not directly to the logic you wanted to access. So our best approach now, or our second approach, is through an SDK. At this moment, we are discussing and we are creating an SDK for multi-sigs. I think we started with multi-sigs, but yeah, proxies is the same idea. The best approach is to do it through an SDK, because through an SDK, we can expose a function so that it couples to a signer, but we can also share that logic to to anyone that wants to use it. For example, imagine that I just want to, I have a special logic for my signer that essentially I build the call data and then I store it in, I don't know, in a USB until, I don't know, 2055, and then I sign or whatever. I want to be able to create the transaction, even though I don't have a signer, right? So it was a bit convoluted to understand. Even though you technically could do it, it was a bit difficult to understand how to create a fake signer actually that helps you with that. So the approach we're taking now are SDKs. And it's not yet released because we are still working on it, but it will be soon. And yep, what we said. Yeah, increase maintainability as well. It's very important because if it's not coupled to signers, we have it like in a separate repo, let's say far away from Polkadot API. It's like a different set of, essentially different set of libraries, right?
Ink is the OG language for smart contract development on Polkadot. So it's a Rust framework to build the smart contracts in that, so that you can essentially like extend the capabilities of Polkadot like beyond whatever the palettes do. Yeah. So it's implemented in Rust, and currently on the version 6, when you build a contract with Ink, it exports a Polka VM file, which is like the binary stuff that has to be run, along with some metadata that we will see later. So for the ones that are not familiar with smart contracts, is that, if we don't have smart contracts, then we have the runtime with all of the palettes, and then our dApp uses each one of those palettes, right? So it can be like a dApp about referenda, it can be a dApp about staking. But if you want to do more stuff, like of course, like you can build stuff that runs on the front end, but then, how do you make this? How do you share this data like along different users and so on? So now you're a bit stuck because like what you can do is like build a new palette, and then you have to talk with the community and say like, hey, I need to do a runtime upgrade because I want this palette inside that will do this thing, which will be like really, really exciting for the user and so on. So like this wouldn't scale, right? So this is where smart contracts come in, which is like, well, we can have a palette of contracts. And this palette of contracts, what we can do is let the users deploy their own smart contracts. So imagine that you want to do like a CryptoKitties dApp, then you can just like create your smart contract about CryptoKitties that will have its own storage, its own transactions, its own everything. Just deploy it, and now you can use your CryptoKitties, right? Or a Ponzi coin or whatever. Like there are so many use cases of this. So like this is a bit the key point. Like, with the smart contracts, you can build dApps that not only that are not only just like a front end and then you communicate with the palettes, but you have your own storage where you can store your own data and it's shared with everyone. And then you will also have like functions that you can run. So there's a set of functions which are the constructors. It's like when you deploy a contract, you just like pass in like some parameters and you have all of those. Then we have transactions, but in the case of smart contracts in Ink, they are called messages instead. And not really sure what is the motivation behind this, but the thing is that they are different from transactions. So when you send a message to a contract, you can essentially make that contract do something and give you back a result. And that contract will doesn't have to change the state. So it's just like you can have a message of even like give me this piece of storage that you have in state, just so that I can read a bit better, and I don't need to fiddle with your storage structure and all of that. But you can also call a message that provokes a change on the state of that contract, and then you have to do that through a transaction. And you also have access to events. So you can make your contract emit events so that other people can be listening to these events and then see how the state changes and whatnot. So this is a bit of the life cycle of, can you see? I think maybe it's a bit small. If I can make it bigger, no. Anyway, this is the life cycle of a smart contract, and I think it's important to notice because, right, like everyone can deploy smart contracts in the chain, right? And depending on how you do it, it might happen that the smart contract that you have published, you can never remove it from a chain, and then you have just like trash sitting there, right? So I think it's quite important to understand like what is the life cycle of a smart contract, so that at least you're self-conscious of like putting the mechanism so that you can actually remove those smart contracts. So everything starts with upload code. So the thing is, you build your smart contract, you have a Polka VM file, and this Polka VM file is the code of that one. You want to deploy it, so when you deploy it first, you just upload the code. Yeah? And what you have in the smart contracts palette is just your code referenced by code hash, and there's an owner, which is the one who deployed it, like who uploaded this code. There's a deposit, so because you're taking up space in the storage, then you have to pay for a small deposit that you will get refunded back when this thing is removed. And then there's a ref count. So this ref count, what it says is how many instances of this code are deployed in the palette. Okay, and this is because whenever you have an instance, and we will talk about instance, then this code cannot be removed. Okay, first you need to have all of the instances terminated before you can say remove code, and then you get your deposit back. Yeah. So now next step. So we have the code uploaded. Now with this code, you can instantiate it. And when you instantiate it, you just like create a new instance of that contract with its own storage and everything in that. So there's like a contract instance referenced by address. So now you have a contract address that you can use. And this one has the code hash so that it can be referenced back to the original code. Then a try ID. So this is the child try that we saw in JSON RPC. Remember that? But when we did like storage entry, there was like a child tree. You can just put in this try ID in there, and then you can access like the storage for that particular instance. And then it has a value. And what this value is essentially how much money does this contract have. Okay, so a contract has this property that is also sort of like a wallet, where users can deposit, can pay stuff, and then this wallet just keeps increasing, or then it can do payouts and whatever, and then it pays out to other users. But this is sort of like the balance of this contract. And when you have this contract, this is creaking a lot. So when you have this contract instantiated, then you can do as many calls as you want, like to change the state. And at some point, there's this self.terminate, which essentially removes the instance from storage. Why is it self-terminate? Because there's no transaction that does this. Like this self-terminate is part of the code that has to call itself, right? So you have to build a mechanism inside your contract of saying like how will this contract terminate? Or if you don't want it to terminate, then sure, then just don't do it. But then be aware that this will be kept in storage forever, and you will never get your deposit back, right? So keep that in mind. Good news though is that now that everything is still like in testnets and everything, the deposit is not that big. But we will see once it gets into the real stuff how that's what's it like. Yeah. Question.
It's always like that you have a contract, and then that contract you instantiate instances. It's always like this in Polkadot, or because if I compare it with Ethereum, that sounds different, right?
No, but in Polkadot it's like that. Like you have a transaction in the contracts palette. Well, now it's Revive, but it's the same. So you have a transaction that's called upload an instantiate that does both of these things at the same time, but it's just doing both things. So it's creating this storage entry with the code hash, and then it's instantiating for you. But there's also like two different extrinsics, like two separate extrinsics. You can first upload the code and then instantiate. But yeah, all of the contracts that are deployed always have this code hash instantiated. And also,
Only one address, right? For this instance.
like each instance has one address, but you
Yeah.
can have multiple contracts.
But the builder does not have an address.
Yeah, exactly. So that's another thing, which I think it's up for discussion. But it's like when you deposit like one code, you're paying for this deposit, but then anyone else can create instances for you, and they can essentially prevent you from recovering your funds. So you have to be careful with that as well. Yeah.
Where do past instances go once they terminate? Are they like is it wiped from storage,
Mhm.
or okay? So you can never really even intentionally like access older versions.
Exactly. No.
Okay.
They are gone from storage. Also, like another question is like, what happens with the value, right? Like when you terminate the contract, what happens with the value? Does it like just burn? And the answer is no. Like self-terminate takes a parameter, which is like the remaining value to who should it go.
Sorry. Does the deposit change depending on how much resources you're using in your contract?
Yes, good question as well. So the contract instance also has like storage deposits associated with that. And whenever you do any call, depending on how much storage does that call add, then whoever did that call has to pay for a deposit as well. And then the deposit gets refunded whenever like it cleans up state. That's
Okay, one more question. So, and is self-terminate the only option to get value out of the instance of address?
self-terminate, sorry?
Yeah. So you mentioned like to get the value out of the out of a single instance of a contract, we like self-terminate. We need to like self-terminate it so that the value doesn't get locked up, right?
Well, no. So the value one, like you can always look at it, like it's in the storage entry. What I mentioned is that in self-terminate, you have to pass an account so that any remaining funds that are in the value will get transferred to that account. But like the contract can say, okay, I want to transfer part of my balance into this account at any point in time. Yeah.
This might be jumping ahead, but like, are there specs that are like implementations for? The question I'm trying to ask is like, Ethereum has different smart contract specs, like ERC20, for an example. So is that something that's enforced, or is that a standard in Polkadot Inc.?
The thing is that it's very in early development yet, so we'll see. If we look at the docs here, use Inc. Here are some examples like of ported contracts from docs. It's here tutorials and examples. I will share this now. But you see, like here's like hello world. But here's like an ERC20 implementation. Then some for NFT. So there's ERC 721 and 1155, and so on. Like here you have multiple examples of these contracts. But yeah, like the main idea is that you're like you can build your own contract and it will just do whatever. Yeah, there's one on PSP20. Yeah, there's PSP22 as well, I think. Oh, this is not in dApps assignment, sorry. It was abstract. This is not relevant for the assignment. PSP22. I think that PSP22 maybe it's in Inc version 5. I'm not sure if it was ported to version 6 yet, but yeah, PSP22 is like the equivalent to ERC20. It was built for a previous version of Inc. But yeah. Any other question? So what I said before of like the message stuff, right? A contract has this concept of a message, and the message can be used both Well, like for 3 reasons. So it can be used as a dry run of like, will this thing have the outcome that I want? It can also be used as a means of querying information. So those messages can return values, and then you will get those. Or it can be used to perform some change. So depending on how you want to use each message, you just need to decide, do I want to, is my call doing any change? Then I use a runtime API that calls that message, and I will get like the value back, and also like all of the events and all of that as a dry run. But if I want that thing to actually do some change, so like I need to pay some stuff, or I buy an NFT, or we will see like in example later, then we need to do a transaction. Because and then with the transaction, I'm signing it, I'm paying for the fees, I'm paying for the money transferring or whatever. But I think that makes sense. So we will see now how we do it with Papi. But first I want to say, so we have like 2 different sort of like levels in Papi. So there's the Ink client, which is, I'm missing the import here, but the Ink client is directly in the top level Polkadot API package. And what this thing does is only helps you encode and decode messages. Okay, so you do pm Papi Ink add, and then you just put the metadata that gets generated from the contract. And then what happens is that in what this will do is create a contracts property in the Polkadot API descriptors that inside will have each one of your contracts that you have added here. And so this PSP22, by the way, it's inside the metadata JSON. Like the metadata has the name of the contract in it, so it just uses that. So you do getting client with that, and now this Ink client will help you like with type safety and all of that, but encode and decode the messages. So this is a bit messy, but it's what we can do at this level, right? Because we just can encode and decode messages. So in this case, what we want to do is do a dry run of increase allowance of PSP22. Yes. So what we can do is like grab the message, and then we have it here. And then we can encode the data that this increase allowance message needs. And this is all fully typed and so on, so you get like full type safety. And this is just like a binary of stuff. And now we can call the API's revive API call and pass in all of the parameters, which is a bit annoying. So right, like when we call a transaction, we always have an origin. We have the signer that calls it, right? So when we want to do a dry run that runs something, we need to pass in who is that going to be. In this case, I'm putting Alice. Now I need the contract address that I also like have deployed this somewhere, and then I have it. And now here are all of the parameters. So first is how much value do I want to transfer to this contract for this call? So I'm saying like, no, I don't want to pay anything. Then these 2 things, which is it's just like a limit on how much do you want to spend. So the gas limit is going to be how much are you willing to essentially pay in fees to do this message. And the storage deposit limit is what you asked before, is that every time that you send a message, if you're increasing the storage on chain, then you have to pay a storage deposit. So you also have to pass this. Now, because it's a dry run, you can just pass undefined, and it will do like unlimited, and it will give you back how much has that costed. So you can take a look and then take a decision with that. And lastly, the encoded data of the contract. Like just to clarify, like this encoded data is just like scale encoding of this, right? So that's not too hard here. This is like one of the differences that it has with Ethereum. Like Ethereum doesn't use a scale, right? It uses its own encoding with the ABI. But in here, for when you're doing like a revive API call to one contract, then you just pass like the scale encoded data. So yeah, we do have time. Nice. We will create our own contract. The only thing is that we will not use this API. We will use the Ink SDK, because this is like not very good, but it's at this level that we can do it. Like, because Papi doesn't know about the palettes and anything like that on the structure, so you have to do it by your own. But if we go to the Papi SDK, now we can say like, okay, if you give me a typed API that has this palette and all of these methods, then I can make the life easier for you. Yeah. So what I have prepared here is this repo that I'm going to share, PBA Bali contract example. And there's only one small thing, which is like the setup that can take quite a long time for the contracts part. So what I would say is like, unless you have like everything ready just by pure chance, then sure. But don't try to follow the contracts part, to compile it and everything, because otherwise you will spend too much time. You can do it later in your spare time, maybe when the assignment is complete. But yeah, like in here in the README, you have like links to the documentations of Ink on how to get started with that. So my idea here is to build a smart contract that will have a canvas auction. So a canvas is, well, a canvas of like with different pixels or tiles. And then my idea is that I want to let users, essentially bid on each one of those tiles, sort of as an auction with their specific color that they chose. And then, it's a bit of like a fun game, right? That you can keep bidding just to make your own, like, I don't know, your own drawing or whatever. So the structure of this project is, here we have the libRS, which is the contract, and it's just like completely empty. It doesn't have, it has like a few utilities that I saw that I would need for this session. But other than that, it's just like the default when you create a new template with Ink. And then I have another folder, which is the Canvas frontend, which has the UI. And I already built the UI, so we don't need to do that. And what it has is this function data, which also has some mock stuff. And here is where we will have to connect it with the actual contract. So just to show how the UI works, how it looks, I have it here. So this is the canvas is like a 20 by 20 grid. And in this mock data, I just have these two squares built in. But then, I can click here, and then I can select an account and with my color, and then I can say, I want to bid, this much amount with, I don't know, like this green over here. So, and then, of course, now it doesn't do anything because it's not wired in yet, but this is a bit the idea, right? Of like having a canvas action that people can pay and so on. Okay, let's go. So first we will build the contract first. And this is, let's go one step at a time. So this is like an Ink contract. It's just like a Rust file that you can define your own types, your own structs, and all of that. And then here we have the storage struct of your contract. So here is where I define everything that my contract will store. So here initially it has a value, but maybe we can think, well, let's go first through the other methods. So then we have this input canvas auction. So this is where we have all of the functions of our canvas. And we have a constructor. So we use like this macro in constructor, and this is what instances the contract. And then here we can have like the messages, right? So this example is a flipper example. So it's just a contract that has a value that can switch from true to false. And we have a message that just flips it, or another message that gets the value. So you can see that this is a message that you would do to actually make a transaction so that it changes state. And this is just one that you just would query. Yeah. So let's set the storage first. So what we want to do is have essentially just like the grid itself, right? And now we have to decide what is the best way of storing a grid of information on chain. Question?
Storing the pixels or the coordinates? Yeah, you have the tuple there, XY coordinates.
Yeah, exactly. Here I have some helper files, helper types, sorry, just to say like, well, a coordinate is XY and a color is RGB. Yeah. But now, how do we actually store it instead? Do we put it like in a vector, in a I like that hash map? Yes, right. Usually, like something that that contracts have is that they have to be very conscious of the time that a message runs, because gas is expensive. So having something that lets you access one particular tile at a time, it's better than having like to iterate through multiple stuff. So what we're gonna do is like have some tiles, which is a mapping. So this is a type from ink, you can see. The thing is that you cannot use hash maps because then it's not compatible. But you can use mapping that comes from ink, and now we need to pass a key to a value. So our key is just going to be a coordinate, and our value, now we just need to put whatever we want in each one of the grid. So we can have a color, maybe, and then for each one of the pixels, we need to remember who paid for that pixel and how much. So that if someone overbids this tile, then we can refund the previous owner whatever they paid, right? Otherwise, it would not be an auction. It would be just like wasting money, right? So color, and then we can do the price. So we will do balance, and then the owner, which is an address. So this is our set of tiles. And now here in our constructor, we have to do, now create this, initialize this one. So we can do just mapping default, I think, default. So it starts with an empty map, like none of the tiles are colored and they are not from anyone. Nice. And then also I'm just like removing the parameter of this constructor. We don't need any parameter to instantiate this. Okay, now let's create a message, and this message will be to actually put a bid on one of the tiles. So I'm saying public function bid, and now what values do we pass in? So when you bid on something, you need to decide which coordinate, which color, and how much. Yeah. So coordinate. Coordinate, and let's color. Coordinate, color, so that's going to be color. And then the value, now this is interesting. Because the value that you want, that you use like to pay a contract, you don't pass it as a parameter to the function. It's implicit in the transaction itself. Like remember like on the revive API that we did like a dry run, there was a value parameter that was separate from the actual call data. And this is because it's not sent as a parameter, but it's inside the message itself. So you have to come here and say like, well, this message over here is going to be payable. So now you're saying like, in here, people can spend money on it. So now that we have this, now we can do our logic of whatever we want to do with that. So let's see. What we need to do is like first check if this bid is overbidding a previous one. Yeah. So if let some tile its self, now self is like our canvas auction. So here we have tiles dot get on coordinate. Then we will do something. Yeah, nice. So if we have a previous tile here that was colored, now we need to do, well, multiple things. First, we need to make sure that the new price that is being paid is greater than the one we had. Yes. So let's do let price. Let's first get like the price that they are paying. So this is through self env value, transferred value. So this is what I was saying before of like that it's like inside the message itself is not one of the parameters. So you say it's payable, and now you can see how much they pay with this self environment and transferred value. You have it there. And in here, now we have the tile. We can destructure this so that it be a bit better. So previous color. Do we need? No, we don't need the previous color. We can just ignore it. Then we have the balance, the previous price, and we have the previous owner from the tile. So now what we can do is like first make sure that this user is paying more than this price, right? So assert that the new price is greater than the previous price. And then I'm going to say, otherwise I will just error with not enough transferred value. So now we have this. And oh, right, now we have a problem because this is part of the revive thing that we will talk about later. But in revive, all of the values come as U256. So revive is an effort to make smart contracts compatible also with EVM contracts, so that we don't need to port and so on. So we have like a compatibility layer. But then this means that instead of working with our balance, which is U128 in Polkadot, we have to work with U256. So this is why down here, I have these two methods, which is transforming from one to the other. Now, let's talk a bit about them because they look like, oh, what the fuck is going on here? So this is still like ongoing work to make it a bit easier to work with, but this is what we have now. So U256 is, of course, like more bits. It's like double the length, but also is like adding more decimals, but like less significant decimals, right? It's not just moving the decimal point, it's just like extending that beyond that. So instead of being 12 decimals, it's 18, I think, 18. So this is why we're doing this, of like, okay, now we take this value. When we want to turn the 256 to a balance, then we take the value and just remove all of those decimals that are not needed, and then turn it into a balance. And then the other way around, we have just to multiply it so that we add all of those decimals back. So let's come here and say like, well, this price, so this way we just can work with our balance. And this is self, because I have it inside my contract, but that's fine. Okay, not enough transferred value. And now what we can do is refund the previous owner of its balance. So again, this is something that's included in the self environment. So here's essentially how you interact with the chain itself. So you have like the hash, block number, timestamp, and so on. But then there's like transfer, and then destination. Well, it's the previous owner, and the value is the previous price. Right? And then in here, we can, like this gives us back a result. So here we can also put an error message of like, couldn't transfer funds or something like that. Oh, so same thing again. Now this takes like a U200, so now we have to turn it back. So self balance to U of the previous price. Now,
who pays the fee there? Is it taken from the smart account wallet value, or
it's whoever is calling this message at this point in time? Good question, though. So, like, think about it, right? Like the palette, or like the like the runtime that is running this transaction, it doesn't know what this thing is doing. It's just like counting how much gas it's spending, right? And then based on that weight, it calculates the fee and then charges whoever did that transaction with the fee. So yeah, this is not paying fees, which is nice. So now that we have this, what we can do is, because now we have paid this, then now we can just add this into our state. So self tiles, insert, and then as key we have the coordinate, and as value we have a tuple of color, balance, and address. So we have the color, it was a parameter, then the balance is the price, and the address, again, it's not something that we can secret. It's like, oh, who has called this? Well, it's also in self environment dot color. So this is whoever is calling this this contract. And well, this is just Rust telling us that we need to pass a reference. So yeah, we now have our bit message, and this should work. The only thing is, I want to do something because in like, I don't know if you can see this sort of problem, but we're not setting a minimum bid, right? So it means that you can always unbid someone by 0.00001, which is like extremely annoying. So I thought that I had here like a minimum bid constant or something. What? Ah, yeah, min bid. Yeah, here it is. So I'm just going to use this in here. So the price has to be greater than the previous price plus the minimum bid. And now we can make it not strict equal. So greater or equal than that. This way, you have to put the minimum bid. Nice. Okay.
Is the minimum bit also thought for so for the first bit, I mean, for every pixel?
Of the what?
Like the minimum bit is thought as well for the first pixel? So
yeah,
for the first time. I mean.
Yeah, for the first time and for subsequent bits, it's the same.
Ah, okay.
So yeah.
Okay. But is it done in?
Oh, no, it's not done. Haha.
Okay.
Good point.
I was just like throwing you a cable,
Yeah.
you know.
You see, I had a security issue in my contract. Oh no. So yeah, if it's not, then we still need to assert that the price is just greater than the minimum bid. Otherwise, yeah, it's someone could hack us. Oh no. Okay, so now that we have this, now what we need to do is a way of getting the current list of tiles. So let's do this later, because I think it's better to see like, otherwise, because you could say like, then you can just access the storage and here you have a map. But it's a bit more hard than that, and we will see why. So for the time being, just let's do this, and then I can just remove this one. And yeah, what I want to do is add a terminating logic to this contract, right? Because of what I said before, I want this contract to end. Otherwise, it will just stay there forever, which is not good. So, right, I want only the owner, so the one that could deploy this contract, to be able to, terminate it. Otherwise, it would not be a good thing. So what we can do is in the storage, we can store who is the owner, so that we can check later. So the owner is an address. And now here, we can just put the owner as the self environment.color. Something to note is that when we are inside a message, we are using self, but as the instance itself, right? We are using the instance that Rust is giving us as the context of this environment. In a constructor, we don't have self, because the instance is being created. So in this case, we can use like the the static version. So self-environment color will still give you the color. I'm not sure if this also applies for others, but otherwise, like it's a good practice just to keep it this way. Okay. Yeah, you had a question. That's true.
That was the same than Carlos. But I don't know if you already said this, but isn't there a helpers also to get like zonable or these kind of things in ink? You could do
Some
like
helpers?
import the library and say is zonable
If you can import what, like
libraries.
yeah, like as long as they are non-STD, then yes.
There are any special ones that recommended by ink, like it happens in with Solidity.
I'm not really sure.
Like it's zonable or okay. So you need to implement always these patterns.
Like we will see later, but the thing is that from a contract you can also call out the contracts, but there's also the idea of precompiles that you can also call things that are actually in the runtime. But in terms of libraries, I'm not really sure. You know, like again, like this is like very in early stages, so.
Yeah.
Yeah. You can.
So I think during your slides you saw like the PSP 22 thing. That's kind of like the equivalent of ERC 20. I think we have two standards in ink, but that's not much. But the so on Polkadot I think when you are going to interact with an asset, you want to interact with the assets that are on the chain. Yeah, so you have pallet assets. You guys heard of that? Pallet assets. You know what that is? Pallet assets. Yes, no? Do they know what pallet assets is? Okay. So yeah, okay. So Polkadot Hub is coming. Yeah, you guys know what Polkadot Hub is. Yeah. So on the Polkadot Hub, you have USDC, USDT, but it's not in a smart contract. It's on the chain level. Yeah. So in Polkadot, you have these chains that are built with pallets. One of the pallets is pallet assets. So that's where people create assets. And the good thing with having these assets there is that you can then, it's easier to transfer those assets throughout the ecosystem. So in order to interact with those assets, there will be precompiles built. You guys know what a precompile is? Yes, no? So precompile is, in Ethereum you have them too. You have them to interact with like certain hashing stuff. And it's basically exposing chain functionality to smart contracts. So it looks like a smart contract, but it isn't. Yeah? Does that make sense? Okay. So now, because there are so much features on the chain level on the Polkadot Hub, there will be a lot of precompiles, and those will have standard interfaces such as ERC20. Yes. So yeah, like we're gonna benefit from those instead of like trying to create a whole like standard ecosystem in ink. Of course, it will have to come a little bit, but yeah. So you want to interact with the tokens on the chain level, not on the smart contract level that much. Well, this is an open question. But yeah, hopefully Polkadot Hub will create a lot of precompiles so that the smart contracts, also the Solidity contracts, can interact with those via these precompiles and not not smart contracts. But those precompiles, they will have standard interfaces that are known by Solidity contracts. And that is then also what Ink will interact with. Did that make sense?
So yeah, let's continue. So we were talking about terminating the contract. So let's just create another message. I'll just copy that. And now this message is not payable because we don't need that. So we will call it just terminate. Mode self. Oh, yeah, it has to be mutable, of course. Okay, and so what we're gonna do here is first assert that it's the owner of that one. So assert that the self.owner is self environment color. Otherwise, only owner can terminate. And now, what do we do? Well, like the easiest one is just like self environment dot terminate contract. And now you can see here what I meant, right? That this terminate contract needs to pass a beneficiary. So this is whoever is going to receive all of the value. So I'm a dictator. I'm going to say that the owner receives all the money. But here there could be like a discussion on like what is the actual logic of this contract and how it terminates. Because if you do this, then people will say like, well, and why do I have to pay you money for this, right? So maybe another thing that could be done is, if this is for a playtesting thing and, for people just to have fun and then, oh, look, we made this picture and whatnot, then maybe what we could have is like an intermediate step first of saying like, close this canvas. And now here in the storage, we would have like, is it closed or not? And if it's closed, then no one else can bid. And then people, can just remove their biddings and recover their funds or something like that. Or there could be like other options. The only thing to note is that it would be a very bad idea. Well, not a very bad idea, but it wouldn't be optimal, at least, to have a terminate function that just goes through all of the tiles and refunds everyone because of what we said that, gas is limited, so you have to be careful with that. It's better to say like, okay, let's put this contract in a state where people just can take out their funds, and maybe after a while, we can just like terminate the contract and will receive the money or whatever, because at some point you want to, recover that.
Would it be better to just, can you make them move their funds to locked? That way it's like, it's not in the contract, but it's locked, and then you just unlock when the bid is invalid.
You would have to use a precompile for that.
Okay.
Yeah. So it's also a good option. But the only thing is that you would need a precompile on Revive that actually lets you access logs and log users' funds and all of that. Yeah. Mm-hmm. Okay, so now that we have this, I think that we can just build. So to build a contract is cargo contract build. And if everything goes right and demo effect doesn't kick in. Oh, another thing that we could do, this is why it's telling me that is that we have a canvas size. So let's make sure that no one is sending us like a dead pixel outside of the canvas first. So let's come here and assert that the coordinate 0 must be less than the canvas size. Otherwise, X is too large. And then same thing for the Y. Y is too large. And this compile. Let's run it again meanwhile, but you can see what this thing exported is a contract file, which is the code and metadata, and now we'll take a look. Then we have a Polka VM file, and this is binary. This is like the bytecode on Polka VM, and then a JSON with only the metadata. So if we look at those files, target ink, oh yeah, it's here, sorry. So here we have the metadata file, and it's similar to a regular metadata, but it's not, right? So we have, we have other properties. So we have like the spec of this contract has this list of constructors, And something that it has is that the types are also denormalized. So it's like the type is this one, and here we have like other information about environment, whatnot, and then here you can see like a list of the messages. So this is one message that takes a list of arguments, and it also has the docs in there. And then the label of this message is bit. So this is the bit message, and then we have the terminate message here. And we have a storage representation of that, and you can see that it's hard to parse. I had to go through this to build the Ink client, so that takes quite a lot. And then the types, which now this is the same format as in the metadata, just a bit more simplified, but also with a few changes of how enums are defined and all of that. But it theoretically, like, it's the same thing. And if we take a look at the contract file, which is the combination of both, what I expected here when I started working with Ink is that this would be actually just a binary, right? Like the metadata encoded in scale concatenated with the actual code. But what turns out is that it's not. It's actually the same metadata, but with additional property that's contract binary that has the whole code in scale, in a hex scale. So it's just, this is like the Polka VM code. So now, how to deploy this? So here I have a script to deploy a contract, but we will not use this to deploy a contract. But we will just like go through it, just like the code, but we will not execute, because I need a signer that I don't have it here, right? I want to deploy it with my signer that I have in my browser, and I don't want to build a UI for this. But I think it can be beneficial to understand how would we deploy a contract. So here I have like just a basic setup of Papi. It's creating a Papi client and connecting to the WebSocket for PassetHub. So this is a new parachain that was deployed in Paseo to try out smart contracts with Revive and all of that. And there's like these two RPCs currently. Then with this, I get the typed API. And another thing I'm doing is just loading the code. So I'm using bun. So this is why I can use bun.file. I pass in the file, and then this as binary, and I have it here. So to deploy it with Papi, we can use the Papi SDK. So, and the Ink SDK, sorry. So it's actually, we're deploying it to Revive. So it's called Revive SDK. I think that maybe I have to, I don't think I have pulled out. Oh, yeah. So it's already included in the package.json, so it's there. But now it's create Revive SDK. So create Revive SDK, and now you can see that what this SDK takes is just the type API we mentioned. And then we also need the descriptors of Ink. So in here, it's not these descriptors of Passet. What we need to do is add the descriptors of the contract that we want to deal with. So I'm going to go to the Canvas frontend, and I do pnpm papi ink add, a little bit bigger maybe. Hopefully it's clear. So it's pnpm papi ink. So now we are in the ink subsection, and then add, and I pass in the JSON file that was just generated. So when I do this, it reads the metadata, generates the descriptors of that, and then compiles again. And now here, if I restart the TypeScript server, is what I said before. So here we have the contracts, and inside the contracts, we will see that there's one for the Canvas auction that we just made. So now we have our Revive SDK. Yeah. So now with this Revive SDK, we can get the deployer. So deployer is Revive SDK, get deployer, and this, we need the code of that. So it has to be binary. So binary from bytes of the code. And now we have the deployer, and now deployer dot. You have two methods. Well, three methods. There's one estimate address to know on which address it's going to be deployed. But then you have two methods, deploy and dry run. So if you want to dry run your deployment, you can just do that, or you can just directly deploy it. So first we need to say which constructor we want to use. So it's new. That's the constructor. And now the arguments. There are many things. So did I say dry run or no, deploy, yeah. So when you deploy, it's mandatory to pass in a gas limit and a storage deposit limit. But now it's like, how do we know this? Like, how do we know which gas limit and storage deposit limit is? Well, you have to do the dry run first, right? Now, Papi SDK knows that this is a bit of a pain of like every time that I want to deploy a contract or send a message for that matter, I need to do a dry run, which is annoying. So what I can do instead is if you give me an origin, so I'm gonna say at the moment Alice, but in here you would pass your own signer. I thought I had Alice. Oh. So in here you would put the SS58 of your signer. And now what this is going to do, Papi, is first do a dry run with this origin to get like the gas limits, and then use those to actually deploy the contract. And this gives you a transaction. So now you can do sign, submit, and watch, and this will get deployed essentially. Yeah. So this is what I meant, that now I have to pass in a signer that I don't have. So I'll just leave it like that. And we will use the contracts UI, which is great, which is in here. UI use inc. I think I had it here. So here, first you have to make sure that you're connected to the network that you want to be connected. And then we can do add new contract, upload contract code, then select your signer. I'm going to sign as Oliva. And then I can load the contract file. So this UI needs the contract file because it needs both the metadata to understand what's in there, and the bytecode as well. So you just pass in the contract file, it has both of them, and it's filled in, it has detected everything, nice, let's go. And now you can see here that it has done a dry run, so the instantiation will be successful. Let's go, and sign and submit. And now it's here, nice. So now here we have our contract that it has its own address. This is basically the deposit that I had to pay as the deployer. So it's just 0.1 paseo. And now here we can, like this UI also has like these methods that you can call. So I could do PBA Oliva. I could say, I want to buy 00 with this color. And then you see it's like contract reverted because the coding error, that's not what I expected. No, I know, because yeah, this is because it's in debug mode, so it's giving messages in string mode, so it cannot decode the error. But it's basically in theory that, it's in paseo. Okay, so I'll just like transfer 12, and you can see now that this would be successful. Yeah, and if I terminate, if I'm designer, then it's successful. If I'm Alice, then it's not. Okay, we have our thing now. Okay, let's continue. So we deployed our contract. This is where we were left at. And now we wanted to connect it with the front end. But here we will run into a small problem, but let's go one step at a time. So as I mentioned, like the UI is already done. We don't need to do any of the UI components or anything. Everything is done. The only thing that we need to do is like connect this data with the actual contract. So for that, I will copy just like the Polkadot, like the Papi setup that there was in deploy contract, so I can just go faster. So I'll just like create a client with Polkadot SDK compat and the WebSocket provider from web. And now the typed API client create, sorry, get type API of, this is Passet Hub. So I call this Passet. And now again, we have the Ink SDK that helps us, interact with with that. So, well, it's actually the Revive SDK because it's published in the Revive palette. Create Revive SDK. It's not importing it, and it's anyway. Import create Revive SDK from Polkadot API SDK Ink. Now, create Revive SDK, and here it's the same thing as before. We need to pass in the type API and the contract descriptors, which were those that were generated. So contracts, canvas action. Okay. So, well, first, like this one, we can actually do. So there's two different ways of doing this. From like, if we look at the Revive SDK, well, first we can get like the contract first. Contract. It's Revive SDK get contract, and this will this just selects one specific contract for one address. So you see, I have to pass the address, which is going to be this one. I'll pass it, but spoiler alert: this contract address is going to get destroyed in a short while. And actually, I'll put it as part of a constant, so it's a bit better. So contract, our contract address is this one. Now, and contract address. And now the SDK, what gives us is an account ID that we can use to get like the value. So when a contract is created in Revive, the address that is assigned is not an account ID. It's this thing, which is actually an Ethereum account ID. So it has like the same number of bytes because it's like all of the contracts in Revive are meant to be as if they were Ethereum contracts. So this is why the address looks like that. But then what Revive does to actually make that contract have a value is it creates an account that can be derived from the contract address. But it's like there's a bit of a logic of like padding some like a specific values on the account ID and all of that. So it's not straightforward. But here we have an account ID, which is just an SS58 string. Like, there's a lot of types, but account ID, it's SS58 string, and we can use this just to do like return. We have to do return like how much money does it have. So type API, query system account, get value. Well, we'll do watch value, so this way we keep track of that. So watch value of the contract account ID. And now here, this is an observable of the account. We just need the actual pre-balance. So we just map that account into the account data.free. Yeah. So this is one way of getting it. But the other way, it would be, I haven't tried this, but it should be there. So the other way, it's through the Revive palette. So if I'm not wrong, the value of a contract, it's also in the Revive palette. Let's see that. It's Revive. And then here we have like a bunch of stuff. So we have like code info for one specific code hash. It will give us like how long is that code and so on. But we have contract info of, and if we do watch value of a key, and now you can see that this key is a file size binary of 20, which is actually the length of Ethereum contracts. So this is essentially this contract right here, which is in hex string. So we need to pass in a binary from hex of the contract. And now if we map the info, I think that in here we should have like a value, no? Oh, Immutable storage. Oh, we don't have it. Huh. Maybe they removed it or something. I recall because like when I did that slide, I didn't make it up. Like that was there. Maybe they realized that it was like duplicate information and they like probably took it out. Anyway, so it looks like now the way of like watching the balance is through the count of that thing. Okay, so we have this thing now. Nice. So if we go to our UI, now this is actually the balance it has. Okay. Now we have another function that we need to do, which is get canvas tiles. So it's just a function that returns an observable of a record of this thing. So it's x and y, x comma y, and the value is the tile itself. So color and price. So how do we do this? Well, we don't have like, if we go back to the contract, we don't have any message that gives us the tiles. But we have the storage, right? So we can see here in the storage, we have the tiles, so maybe we can access that. Let's do this. So Ink SDK also has a storage. So storage, it's the contract. Oh, sorry. Yeah, it's contract.getStorage. And this gives us like the storage API of this contract. And now here we can do return storage. Now we have two different options. Get nested, get root. So if we take a look back at the metadata of this contract, we have this like big storage that has like a lot of stuff. This is setting a layout because in the storage on smart contracts is not just one big value. You can have mappings and stuff, which we have used. So in here, it's defining something with a specific key that we have to access that has 3 values, A, B, C. So that's probably one of the coordinates. And this is like a struct, OK? And it's inside another struct that has another thing that has another color. Not sure how. Oh, so these are the tiles, yeah. So these are the tiles, and the tiles, it has sort of like another root that we can access. So like the way that the storage is structured here, like it's essentially like it's nested storages one inside the other. So there's a root storage which has some properties. So this is the canvas auction, and the canvas auction has some tiles that inside has another root storage that has more properties. So like this is a nested storage, whereas this one, which is the owner, it's directly in the value. So if I want to access the owner, I can do get root, and then get root is a promise. So, and if it's success, then the value has the owner, and the owner is right there, right? But now the stuff that's nested, it doesn't come with the root storage. When you query to the palette of like give me the storage of like this palette, it only gives you the values that are like flattened out there. If you have some mappings, it doesn't give you them. So this is like now part of the Ink SDK that for the things that are nested, now what you have is a function to get that value that's nested. So you can call it, and this will return another promise because we have to load this again. So in this case, we want to get the tiles. So we can just directly do get nested, and then what nested storages do we have there? It's just the tiles. So this is all we can select. And now we have a problem. Because to get the tiles, this is a map of a coordinate, x, y, to the actual value. And we don't have a list of keys. Also, that's another thing that the storage has, is that it's not iterable. You cannot say, like when you have like a map or a vector or something like that in your storage, you cannot iterate over it. And this is done for gas saving purposes and whatnot. But now we have sort of a problem because what we need to get is all the 20 by 20. It's 400 tiles. So we would have to do 400 requests in order to get each one of the tiles, right? Because we have to get them individually. We don't have a get entries here, so that's too bad. So this is why I said like we will have to throw this contract away and create a new one because we need a proper way of accessing this. Okay. So what's the proper way of accessing this is creating another message that it won't be payable. It's not meant to be like called as a transaction. But people can use it to just read from the value. So I'll just copy this just to have like a function signature. And this is going to be get tiles. And what it will return, maybe we can do a vector, just to keep it simple, of each one of the tiles. So the tile will be the coordinate, and then we have the color and the price, which is a balance. Oh, but yeah, and then this is fine. Yeah, like this is everything we need for like we need the coordinate, then the color, and the price of that tile in order to return this. So in here we can iterate because the thing is that this is not going to be a transaction. It's not going to be like called every time. We don't have to pay gas for this, right? Only the node that we will be asking, can you get me the tiles? We'll run this function. We'll just like go through all of them and we'll give it back to us. And only that node will execute it for us, like completely free, which is really nice for really nice for them. But yeah, and this is much better than doing 400 runtime calls of give me the storage value, give me the storage value, give me the storage value, which is not great. So let's do this. So let's put like a result. It's vec new, and we will return result. And then we have the canvas size, which is 20. So for x in 0 to canvas size, and then for y in 0 to canvas size. We can get the tile, so we'll do if let some tile it's in our storage. So we can remove this mutable reference because like this won't mute anything. So self dot tiles dot get, and then the coordinate is xy. So if we have the tile, then result push, and then the coordinate, which is xy, the color, which is tile. Let's destructure this. What was the structure of this? It was coordinate, it was color, balance, and address. So yeah, we need color, the price, and the address. We don't really care about it. So, and we return the color and the price. And it's probably missing some enter. Oh, mute. Okay. So I think that this should be enough now. So now we have to build our contract again and deploy it again. So cargo contract build. And I'll come here and I want to get my deposit back. So as PBA Oliva, I'm going to terminate the contract and I'm getting my money back. And oh, right. So this back, now I'm having some PTSD from fundamentals, but this back is one of these that is no standard, but I have it here prepared. Don't worry about it. So now everything will be fine. So like you can just import back from inc prelude backpack, and this should work. Also, note that passed hub sometimes, maybe, I think here I have passed hub. Yeah. So you see that the transaction I made took a long time. It was because of this. So this Papi console, it shows you all of the blocks, but also it shows all of the forks. And sometimes this parachain has these gaps where validators cannot talk to each other for some reason, and so they just cannot. They stall the chain. So for sometimes they all create like blocks and more blocks and more blocks and more blocks. But then after, like, usually it's like a minute or something like that. But after a while, everything comes together, grandpa kicks in, and we have finality again. Okay, so this has been removed. I can just forget it. And now this has compiled. I can upload a new contract as Oliva and pass in the contract file, which has both the metadata and the code. Next. Next. Upload. Okay. And now in Papi, we need to refresh the metadata file, right? Because we are using the old one, so that if we try to call the message, it will not work. If I go contract send, for instance, it's one to send a message, we can see that we only have bit and terminate, but we're missing the other one. So the way of doing this is going back to the Canvas frontend, and here we do pnpm papi inc add again, saying like, hey, you need to add this contract again that now has changed. And now it's telling us, well, it's replacing the existing Canvas auction. It's replacing the existing Canvas auction, but this is fine because we know that we just made an upgrade. So now this will work. Startup script server. And now from here, I have the address again. And I think if nothing blew up, now this should be the final address that we can all use to play around with. So I'm putting this up. And now we have to fill in this function. And now we can. So what I want to do with this is return an observable that has all of the tiles in it. So if I look at the contract at the Revive SDK, so I have my contract dot, and now I can do a query. So the Revive SDK has two methods to call messages. There's like query to do dry runs and ask for stuff, and send that actually does the transaction. But in this case, we only want to query. We don't want to send anything. And now we're going to see that it's like bit terminator or get tiles. So we do get tiles. And now we need to pass an origin for the same reason that, when you do a dry run, you need to always give it an origin. So the origin I'm going to put here is Alice, because it doesn't really matter. We don't do anything with the origin in this contract. So I have Alice up there, and I can have it. But what I see here is that this query is a promise. Because a runtime API, you cannot watch it, right? Like a runtime API, you just call it and you get it. But I want this thing to be live. I want this to be an observable. So what I can do is that every time that I receive a new block, I will just call this again. So we can do this with Papi in client dot. Now we have like different options. We could go to the finalize block, but asset cap is extremely slow, finalizing blocks. So what I'm going to do is just go to the best block. So best block, I can return this already. So every time that the best block changes, what we will do is, what do you think is the best mapping function here? You saw the spoiler. So in here, it's one of these things that it could be argued, right? It could be like, oh, it's a switch map, because if there's a new block, you have to cancel and start a new one. But I think that actually it's probably best the exhaust map in this case. Because the best block is going to change every few seconds anyway. And if it's changing too fast, because the best block can change like multiple times, right? Then what would happen is that we would never read the tiles, because the get tiles is going to take. So I think that in this case, exhaust map is a bit better for that. So whenever we need whenever we do another thing, we just get the tiles, and now we can take this result, which is now whatever was defined in the contract, which is like quite big. We can now map it to our thing that we're expecting, which is a bit more clean. So let's take there's a result, and what this result is like this, that, well, maybe it succeeded, maybe it didn't fail. Like, we know that it will succeed because we're awesome. But in case it doesn't succeed, result success, then we will return an empty record and call it a day. Well, maybe you can log a message just in case. Console error, the result. And result is the actual error. Otherwise, we can just return our stuff. So usually the way I do is this is with return object from entries. Again, each one to their own style. I'm sorry for this, but now I have every single tile, so I can just map them into what I need. So I have what's the response. So here, like I have also like the events the thing has generated, the gas required from the dry run, the storage deposit from the dry run, or I could also like try to send as a transaction. In this case, it doesn't make sense, but anyway. So I have the response, and this is an array of each one of the tiles. And now each one of the tiles is a tuple of fixed-size binary. Well, why is that? So I can see there's, well, in theory, like this, what we saw, it was that this thing is returning is coordinate color balance. So we can give it at least in this name already. Coordinate color and price. But, oh, yeah, I know. But coordinate is a fixed size binary of 2. It's not a tuple of U8s. Why is that? No, it's not in shenanigans. No, it's already decoded. But it's a good guess. So this is actually what Papi is doing. This is actually our fault. I'm sorry about that. Okay? What happens here is that Papi, every time that it sees like a vector of a U8 or a fixed size binary of U8, it thinks like that's binary data, right? So the problem here is that our contract has a coordinate which is a tuple of U8s. So Papi looks at this and says like, oh, this is binary data. So this is why whenever it decodes it as a fixed size binary of 2. But anyway, like you can get like the values, the raw values from that with no too much hassle. So let's do that. Like we can just, I think that we can even do this. So we just destructor x and y from coordinate dot as bytes. And now x and y are both numbers and they are the things. So this is like it's not a problem. It's just like this thing that Papi has that, oh, when it sees something that is a binary, it's like, well, I put in this as a binary because maybe you want it as an array, or maybe you want it as a text, or maybe you want it as actual binary information. So you can just do that.
But I mean, in our defense, kind of notice that the type is telling you that it's a fixed size of 2. So it's basically the type is telling you exactly there are 2 binary, so there are 2 bytes in here, right? So yeah.
Exactly. So we have the coordinates, the RGB, and the price, which is already a bigint, which is a balance. So that's awesome. And now we need to return the key and the value of that. So the key is X and Y. And the value is color and price. So color, I have here a function that I've done before to turn like an RGB, or is it? No, it's like in a lib file. Color, yeah. So in here, like I have a small function to turn it into RGB. So RGB to color of RGB, just importing it. And the price, I just can pass it away. And this should almost be working because I forgot something. So remember here that I'm saying that because passed cap is so slow on finalized block, I want to try it on the best block. The only problem is that Ink SDK by default also uses the finalized block. So we need to tell Ink SDK here when we create it, there's like an options parameter that you can say at best true. So now all of the interactions that we do with the revive SDK, it will be at best, and then it will be a bit more interactive. Otherwise, the canvas is extremely slow. And in here, we will also do what's value. Sorry, it's already, I thought it take that, but No, you see that there's an optional parameter which is at best or finalized. I want this at the best block. Okay. So in theory, now it should be working. I'll give it a. Ooh, that didn't look right. Ooh. Message get tiles not found. Did I update the contract address? No, I think that this is Bits doing because it didn't. Yeah, no, this is Bits doing. Like, it's the bit catch. Because when I updated the contract code, it got updated in the node models folder, like for the Papi descriptors, and then Bit is like using the old version of that. So I'm gonna kill Bit, sorry Bit, and remove rf node modules, and then it's like this folder here, like it's a hidden folder inside node modules that has all of the Bit catched stuff. So now I can do pm def again. And okay, we have our canvas, and I'll try to buy this pixel over here as Oliva with an olive color and submit. Oh, oh my God, I'm also quite asleep today. So we were missing a function which is like vital, which is submitting the actual transaction. I'm sorry about that. So okay, like at the moment we can just like read values, and the canvas will update as people keep bidding, but we need to actually do the bidding, and this is also easy. So we have contract, and now we want to send the message before we query it. Now we want to send the actual transaction. So send, which transaction we want to send is bid. And now for the arguments, here's the same thing. We need to, like in theory, we need to pass a cache limit and a storage deposit limit, but we can just pass the origin, and Papi will calculate this for us. So I'll pass the origin, and now it has to be the correct origin. Like if I pass Alice, maybe I get like a different storage deposit or whatever. And then the data is a color and a coordinate, which again, it has to be a fixed size binary, but this is okay as well. So the color is a binary from array. Oh, we had from array before. I had from array. From bytes. Pretty sure I had like a from array before. I'm not. What? I'm extremely confused now. Well, anyway, I can just like use I can just use this as well. So it's a bit more verbose, but I can do binary from bytes and pass just like uint array, and the color is RGB. Oh, RGB. Why it's not? Oh, because it's color.r, color.g, color.b, and the coordinate is again binary from bytes, new uint data array, and this is x and y. And I'm missing another piece of information, which is the price. That remember that it's not part of the data; it's part of external. So this is the value. The value that we're transferring is this price. And lastly, we just need to sign. So we need to return this in order for the thing to catch the value. So return this and sign, submit, and watch with this signer. Okay, let's see. So I'm going to buy, I don't know, like this tile again with some tokens. What did I do wrong? Sign, submit. Is it because like I have to return a promise? I think I have to return a promise instead of an observable. Of course, I need to return a promise. This is not being handled by, like, well, this should be handled by this guy. I'm sorry. what I need to send then is, I'll do last value from, sign submit and watch of this, but now I want it to stop whenever we receive the best block event. So pipe, and I'm gonna do take while the event that we're receiving, so the event type is not best block state, or if it's best block state, then it has to be found. It's some of the properties here. So now this last value from, it will subscribe to our contract, to our transaction being like sent and everything. And when this transaction gets in the best block, then we're done, and this will let you know that. Let's try this again, please, for the last time. Some tokens, submit. Oh, nice. So if it's disabled, it means that it's loading, so it's going there. I could have actually like logged the messages or something. Suspension is killing me, and maybe let's see this. Oh, this is still. Oh, come on. So this used to work this morning. Now it seems like the transaction, for some reason, the transaction is going through. Oh, and it went through. Yay. So I'll commit these things as if you want to play around and, like spend your money into that will fund my account. That's that's great for me. But yeah, question. You, yeah.
Can you batch transactions or like just purely on the front end, or if say you wanted to place multiple bids at once?
Yeah. Like you could batch them, right? Like in here we're just submitting one, but when you do, well, that's a good question. Sorry, no, right. So you see, like this is a feature for the SDK if you want, right?
Yeah, I imagine there's two ways. One is just like multiple wallet pop-ups, or
you can still do it, right? Like if you want to do multiple, like let's say that when I call this function, I want to buy the XY, but also the next one.
Yeah.
I could do here. So transaction one, transaction centered, or I don't know. Transaction at the center is this one, and then cons side, and then I can create another transaction, putting here x plus 1. And now I could just create a utility batch, right? So I can do now the transaction I'm going to submit, instead of being one of those two, it's going to be, so I can remove this, it's going to be tight API, transaction, utility, batch. And now here I pass in each one of the calls. So this would be transaction center dot decoded call, and I know getting.
Yeah, because it's an asynchronous.
It's an asynchronous function. Yeah, I will have to do this, but anyway, you would do here a wait promise all or whatever with a better. But like essentially, this is the idea, right? And then I would do like the side transaction, decoded call, and now what I'm signing is just the batch of the both of them. Yeah. So maybe like if you open an issue on the SDK, I will tell you, no, you can do it yourself outside in this case. There was a question back there.
Thank you. Somewhat similar. How would you do gasless transactions or gas-sponsored transactions? Maybe it's a really pretty irrelevant, but like how could you pay for the gas on behalf of your users to interact? I mean, obviously that's not a use case for what you're building, but for other smart contracts.
So as far as I know, like every time that you do the transaction, the fee that you're paying like the gas of that call.
If I want to pay the gas fee for my clients to use that,
You need to do that on the chain level. Yeah. So you have in Substrate, you have like a way to pre-sign a transaction. So you pre-sign, I don't know, I'll do a balance transfer, or I call this contract, and then I give that data and the signature to someone else, and then they submit it, and then they pay for the transaction fees. That's one way.
Any other way we can provide transaction fees, and then they would just have the rest of the transaction.
So you can. So essentially, I think I explained a way of doing this, or different ways of doing this. But the thing is that we need, so you need a palette that actually does this in this point in time in Polkadot. You would need a palette of gas-free transaction or whatever, right? And then you have so different. There can be a different way of authenticating through this palette. But with extrinsic v5 that we explained the other day, there could exist one sign extension that instead of verifying a signature, it's like check gas fee transaction signature or whatever, and then that logic could authorize you even though you are not paying those fees. So another entity is paying those fees for you, but still this has to be done at a chain level, either through a palette or through a sign extension. There is no other way.
I mean, even without extrinsic V5 facilitates this quite a bit. But even without extrinsic V5, right now, the transactions that are being used in Palette Revive for Ethereum are all unsigned transactions. And then inside, there's a payload that includes like the Ethereum-like transaction. So you could even use that, right, to allow for certain contracts to pay the fees for you if you want, but only through Palette Revive and through this path. So it's a little bit, but yeah. I mean, no, like not in production, but like in perhaps in Passive Happy's. Okay. Yeah, I mean,
Well, I was about to commit the thing, and then I found the problem that our transaction was taking so long to go through, which is that this, I was waiting until it was, sorry, it was like that. So I was saying, take the messages, like, so keep sending messages. If it's not on best block, but if it's a best block, if you're found, if the transaction is there, then keep sending messages. So the last value from was not kicking in, right? I missed that this is actually the opposite. It's like, well, if in a best block it hasn't been found, then continue. But if it has been found, then stop taking more messages. So now, after doing this, and I'll commit now this thing and hit push, because I'm sure that this should now, unless the chain is stalling now, which could happen, but I'll pay some more here. Sign. And I'm confused because this is not doing what I want to do. Like, it should be logging messages, and it's not logging messages, and I'm panicking. Because I killed the server, so it's not running, so it didn't load. It didn't refresh. Anyway, you get the idea, right? So npm dev, canvas frontend, npm dev. So here's the one I bought, but if I take another one, like IVP didn't want to connect. Today it's not a good day for making demos. now, put the last time. Submit, signed, broadcasted, and test block. Now it's fast. Okay. All right. I think that maybe we can take like a 5-minute break or something like that before we continue. Yep. And there's not too many slides after this. Like, don't worry. And later on, we can work on the assignment and all. So. I'll mention this after, like, when everyone is back again, but there's like an important thing that I forgot to mention is that if you want to participate with smart contracts, like either send messages, deploy, and all of that, you first need to do an extrinsic by your own. So you need to call revive map account. So you submit this extrinsic with the with the account that you want to participate with smart contracts, and then that account can deploy smart contracts, call smart contracts, and so on. I'll explain why that's the case after. So something I forgot to mention, and some people left, but then for the ones that were here, then I said, is that on Revive, if you want to do something with contracts, first you have to map your account. So there's just like one extrinsic called Revive map account. You call this thing, your account becomes mapped, and then you can use it like to deploy, send transactions, and all of that to smart contracts. This Revive map account creates some storage entry in the Revive palette, so you have to pay for a storage deposit. If you want to recover it back, then there's like another, like I think it's unmap account, and then it removes you from the storage entry, and you get your deposit back. Okay, so you might ask, why is this needed? And the slides that we have now will go a bit deeper on this, but the main thing is that Revive is this palette that is meant to be compatible with Ethereum. So all of the addresses it works with internally are Ethereum addresses, which are these like 20 bytes. Whereas the account ID is using like a longer public key. So there's a process of turning your account ID on Polkadot into your own address 20 of Ethereum. Right? And this is a hash function, essentially, that's being applied. So Ethereum, Revive, in order to work, needs to be able to know, like, an address that's in, like, in this format of 20 bytes, what is the actual account ID that it belongs to. But it's a hashed version, right? Like, it's a hash that has happened, and you cannot undo a hash. So this is why it needs that everyone that interacts with it to have their account mapped, because like this is essentially, if we go to storage, Revive, we have some place here, our original account, where you can see that in here you would put your like your Ethereum-like address, and then you get back the actual account ID. Okay. That's it. Because like someone tried to deploy this contract and they couldn't, and it was because of this reason. But it's, you just call this once, your account is set up, and then you can do all of the things that you want to do. Okay, so we go back to question.
Okay, so is it possible to like verify our contracts like we do on Solidity with Ink?
Verify? What do you mean with verify?
Okay, like on Solidity, wherever you verify your accounts and your contracts, you can actually see the source code on the Explorer.
So the thing is that the source code is not published. So if you go to the contract, all you can see is like the account, like the code, and that's all. Like you can have the blob, but then from that blob you cannot revert it back to the actual source code because it's like compiled, right? So how do you do this? Well, like someone could create something like in Ethereum of like a map of like, oh, this contract has this code and it's all verified and whatnot. But you could also take the contract, compile it, and this essentially would have to give you the same hash. So now you can see that this that instance of that contract, it's so that instance of that contract has a code hash, and then you could verify that the code hash is actually the same as the contract that you just built. So it's like, oh, from the source code, it's a bit more time, but like, yeah, we don't have this structure just yet in Ink, essentially.
Yeah. So as soon as Polkadot stable is ready, or Polkadot hub is kind of like ready and people are able to deploy contracts there, we know how this is done for the Solidity contracts, which will be via the same way as you are familiar with. And then for Ink, we want to make that like using the same tooling. How exactly? It's not 100% sure yet, but yeah, it will work all the same, basically.
Yeah.
But yeah, take into account that this in Ethereum world is also an off-chain process. So it's something that it's not on-chain. So when you deploy a contract in Ethereum, you don't push the source code. So there is a tool called Sourceify in Ethereum that does this. I suppose you were referring to that. But yeah, take into account that it's not. So I kind of grasped from the comment that it seemed like in Ethereum you push the source code. This is not this way, and it's not this way neither on Ink. Yeah.
Okay, let's go into Revive now, which is this quasi-compatibility with Solidity smart contracts. Okay, so in Polkadot we have had contracts for a long time, but they were on Ink version 5 or before, and they were contracts that were compiled to WASM. Okay, so there was one specific palette, which was palette contracts, that was the one that instantiated this WASM of the contract and just called them. The only problem is that, well, like they worked, and they worked really nice. The only problem is that they were not integrated into any of the system chains. So they were isolated in, either like in test networks, or there were like some specialized chains like Aleph0 that it also didn't go live. That was meant for like some specific use cases, and then they had the palette contracts to work with them, but it wasn't like explored further. So at some point there was like this this idea from Polkadot, which was called Plaza, and Plaza was like, hey, like we have so much stuff like scattered around, like we have like in Asset Hub we have all of these assets, but then on the Polkadot relay chain we have balances, but also we have like the staking system, but we also have governance in there, and everything isn't connected and so on. So there was like this idea of what if we bring everything that's useful into just one single chain, so that it can play around with it. So the idea is to bring all of the assets, so USDT, USDC, wrapped ETH, wrapped BTC, and so on, balances, but also smart contracts. And the idea was to support both Inc. and Solidity, so that they could bring external contracts, but also like the other palette, so staking, governance, and bridges. So this is now part of the migration that's happening. So this is now part of the migration that is happening on different test chains, and so far it's not going that well, but we're getting there. But the idea is that at some point we'll have a migration happening on Polkadot, and then all of these things will be in Polkadot Asset Hub, together with smart contracts, which will be really nice. There was a comment there. Yes. Yep. Exactly. We have the different names for that. Initially, it was called Plaza, and then we have all of the names, but it's all the same thing. So now we're talking about contracts. This is now the magic of it, and this is the truly potential that we now have. Previously, smart contracts were in those chains that were too specialized, but now the idea is that we can write smart contracts that are running in the same chain as all of the other stuff. So we theoretically will be able to write smart contracts that work with assets, balances, staking, governance, and all of this. So this is how Revive came in, and Revive is now a new palette. And the main goal of this palette is to bring existing Ethereum contracts into Polkadot. So this is why everything in this palette works with Ethereum-like addresses, so which is these 20 bytes as hex. But now we need a way of mapping from previous, from Polkadot addresses to the actual Ethereum-like addresses. So when we want to turn an account ID to hash 160, which this 160 is because it's 160 bits, what we do is do a kekak of the public key, which is just the actual account ID, and take the last 20 bytes of that. So this gives us a hash, and this is the Ethereum-like address. But then, if we want to do the opposite, then we need to, store this mapping, because we cannot revert the kekak hashing. Now, the other one that I have here is because sometimes you have the opposite. You have an existing Ethereum address, right? Or even a new Ethereum address, when you deploy a contract, it's deployed into Ethereum address, right? And you want to know what is the account ID of that one. Then what we do is we just pad that account with some constant up to 32 bytes. And now this is the account ID, and this is how we actually got the value of the contract in our dApp. We just use this thing. So now the way that we have to access each one of the other palettes is through precompiles. So this is something that previously Inc. Already had before, that is from a contract you can just call other contracts. This is very common also in Ethereum. And you have your contract, you can call some other contract in this contract and call other ones, right? And they can even instantiate it themselves and so on. So there's this idea that we can create a precompile that from the perspective of the contract, it's just another contract. So it just gets imported as if it was another contract that you just call a function. But what's really happening is that this is actually inside the runtime. So you need to do a runtime upgrade to have this. And now this, because it's inside the runtime, can now do whatever with whatever palette that you want to to interact with. So in this case, it's assets. So here I had like I had planned a practice of like using a precompile. The only thing is that I couldn't manage to get it fully working because it's still a bit green. There's like ongoing work that Dan is now working on it, but we're getting there. But what I can show you is a bit like how it looks like. And in this repo that I have shared, I have here a branch of like precompiles, and I have whatever. Okay, so I have these precompiles, and if I go back to our code, I can just show more or less how it looks like. So canvas action. Oh, and the actual code for the precompile, I don't have it here, but this is like how from inside the contract you would call a precompile, essentially. So the idea is that first you just define what is the interface of that precompile in your contract, or you could even like build a library that you just import it and so on. But the idea is the same thing. So you import it as a trait of like this is the precompile function that I can call. Then you need to get the address of this precompile, which is just like a regular address. The only thing is that this works with a slot system. So the thing is that when you register a precompile in a runtime, you need to say like this precompile is ID 234, something like that. And now there's a function that can also like be exported into a library or whatever that given that ID, it just like generates the address for that. And so now that we have the address, now we can have the function that actually calls the thing. So this is, I don't know how to do this. So here you can see that in this case, the precompile that we want to access is one that's called burn, and is one that is used to burn tokens from a contract. So you can say like, oh, I have, I don't know, like 1,000 dot, I want to burn 200 because I want to reduce inflation or whatever. So you would first get the ID of that one, which is like 11. So now I have the precompile address, and then I can instantiate like that connection by passing all of the parameters. So this is like the interface that we saw up there. And now this is like which environment to use, which is just like default. And now this is a bit more important. Like this is telling which ABI, like which kind of communication it has to do with that specific contract. So this is Solidity. All of the precompiles work with the Solidity ABI. So with this, we're telling our contract ref macro that it should encode and decode messages using the Solidity ABI. And it just turns it into precompile. And now this precompile has the method that we can execute on. So there's like precompile.burn, and we just pass the amount. And I don't know what this true was. Oh, if you want to keep the thing alive, right? Which makes sense. But again, like I really wish I could have done this practice, but I did not manage to make it work. So I think that maybe Solidity, I can just introduce it, and I'm not sure if we can do a practice on that, because again, like it's not. It sounds like really, really great. Like maybe like if there's a lot of people interested in it, we can take a look into it, but it's not that impressive. But I think that the content behind it it's interesting. So again, like Revive was created to make Solidity contracts run in Polkadot. So through Solidity, so there's like this package called Revive that takes Solidity code and compiles it into Polka VM, right? And the initial idea was that Palette Revive would just run Polka VM, and then you have like Inc contracts compiled to Polka VM and Solidity contracts compiled to Polka VM, and then it would work. This is why it was called quasi-compatibility, because there's like always some edge cases with that. But like this was the idea. And then what else we need is like some tooling support, because we want the existing Ethereum tooling. So we want, for instance, MetaMask to be able to sign a transaction and send it to our contract. So we need some custom RPCs to accept this kind of interactions with existing tooling, basically. So more or less, the codes look like that. It's like, okay, you have your dApp, and with this app, you have your contract, and then you can choose if you want to use like Ethereum tooling or Polkadot tooling, right? If you use Polkadot tooling, then you're using the regular addresses, and then you use like the light client or Polkadot RPC that does a revive call transaction, and this revive call transaction calls the contract. Or you can go through the Ethereum tooling, and now this Ethereum tooling is the one that's signing the transaction using that API, right? And hits directly this Polkadot Ethereum RPC. There's a question there, or a comment, or one.
Sure. So if it has to go through a centralized RPC, is it really a dApp?
I mean, it does. Yeah, I mean, it's a centralized that's going through this RPC, right?
Yeah, but with that option, I can go through a light client and can
Yeah.
verify everything. Yeah, so if I go through the ETH RPC, I don't know.
In
Is
this,
it
in
dApp?
this case,
Just
yeah,
food
just
for
leaving it
thought.
there, right? Leaving it there. Okay. And then what happens here is, how do we actually get this message into the runtime? Like the runtime talks scale, and Ethereum tooling doesn't talk scale. It just talks Ethereum API, right? So this is why we have like this RPC over here that's essentially like just getting the actual message of like the Ethereum tooling, which is like just the transaction itself, the Ethereum transaction. And then what it does, it calls Ethereum transaction, but that's unsigned. So let's go here, because I see that many people are like, what is this talking about? Okay, let's go. Like so many stuff here. And just call it. So if I go to Asset Hub, so also like note that namings are hard. So if you put Asset Hub, there's like, oh, there's Polkadot Asset Hub. This one doesn't have contracts yet. Then we have Paseo Asset Hub, which doesn't have contracts. It's Paseo Asset Hub, okay? And this one is the one that has contracts. It doesn't need it. So Asset Hub. Yeah. Yeah. So again, if we want to like call if we want to call a contract in Revive, we can just have this extrinsic of like Revive call, and then here is like the contract address, and we can like put a price, and then we have to put the gas limit and whatnot. And here we have the data, and this data, if you're hitting an INC contract, it's scale encoded. If you're hitting a Revive, a Solidity contract, then it's API encoded. But you can also have this one, Revive F transact. And now what this F transact does, it just takes a binary, right? And what this binary is whatever MetaMask has signed. It's like the Ethereum transaction signed with all of the information in it. And due to this transaction, Revive F transact completely unsigned. So if I come here and I do like 0, like this is going to fail, of course, but you would do submit without signing. And now the transaction is invalid because, well, this transaction is invalid, right? But the idea is that this transaction can be called unsigned, and it's called unsigned because this guy over here is the one that is sending it. It's just an RPC. The RPC doesn't have a signature, right? It's just taking whatever the Ethereum tooling is sending it and just passing it as an unsigned transaction to this guy over here, to the runtime. Now, this one is the responsible of now looking at this transaction and verifying that the Ethereum signature is actually correct. And it does that And if the signature is invalid, then it's like, no, this is invalid. This cannot be accepted. But if it's valid, then it goes through to the actual contract. So you can see like that there's like, well, the main idea of like all of this path is just to let existing Ethereum tooling, but like theoretically, MetaMask will not have to make any sort of change in order to be able to work with Polkadot. Questions?
For off-chain real-time data, for example, is in Ethereum, there's oracles that you can use. Is there going to be tooling in Polkadot for similar stuff?
Yes, like in theory, like that's the thing, right? It's still something that we're building, so we will get there. So at the moment, we don't really have anything like that. But the idea is that we can replicate whatever the ecosystem we have in Ethereum now in Polkadot. Okay, so if there's no other questions, then this is it. This is the last lesson. Oh, before we leave, I wanted to mention that there are so many initiatives in the Inc. community that they are looking for builders. They are always like organizing hackathons everywhere. Like the community is just going strong essentially. So if you want, like there's like some it's okay, incubator. So like for instance, like these are some that are even like financing some projects and so on. Like it's a good community. Like even though like it's still growing and all of that, and it's not yet ready, we're always like looking for developers and so on to give this a try.